Good Monday to you. My name is Mr. Royce. I'll be your AP Calculus AB teacher today. We're just going through homework problem 3C, which is part of the homework due today. We took the reciprocal of both sides. We rationalized the denominator to get down to sine theta equals negative root 3 over 2. So the M.U.C diagram that you should have had for problem 3C should have had the following features. A rim, since it's sine a y-axis. What's going on in your mathematical imagination, by the way, is all possible M.U.C diagrams, where M.U.C stands for mini unit circle diagram. Here's all possible mini unit circle diagrams, but the one we want is negative 1/2, negative radical 2, negative radical 3 over 2. That's the one we're trying to draw. So let's try to draw that one using all 7 features. Y-axis, the vortex are at negative 1/2, negative 0.71, negative 0.87. This time we want negative radical 3 over 2, dotted line, perpendicular to the axis through the clearly visible axis point, helps us locate the terminal points. So there's a M.U.C diagram. So we're going to start our search for solutions at negative pi over 3. And there happens to be one right at the beginning. So we get theta is an element of the set. Negative pi over 3 is the first one we encounter if we start our search. Think of this as a floor. 5 pi over 3 is a ceiling. We're going to search from floor to ceiling for solutions. So negative pi over 3, we got one. Keep searching. 0. 1 pi over 3, nothing. 2 pi over 3, 3 pi over 3, 4. There's one, 4 pi over 3. So the second solution is 4 pi over 3. Keep going, 5 pi over 3, but wait, there's a parentheses on 5 pi over 3, there's a parentheses on the ceiling, which means it is excluded from the search. Had there been a square bracket on the 5 pi over 3, there would have been 3 solutions to this equation. 5 pi over 3 would have been included in the solution set. But as it is, as it stands, there are only 2 solutions to that one. Are there any follow-up questions as to what was going on with problem 3C on the homework due today?
So where did you get negative pi over 3?
In the directions, it stated, and I can just pull that up briefly in case you didn't realize it, there was, when you go to classes, AP Cal period 7, heading topics, and it was in problem set 5. So when you look at problem 3, letter C, they gave you a search interval. They gave you the floor and the ceiling for the search. Are there any other questions on problem 3C? By the way, in D, when you take the reciprocal of both sides, hopefully you had cosine theta is negative radical 2 over 2, because negative 1 over radical 2 becomes, when rationalized, negative radical 2 over 2. So just FYI, the M.U.C diagram for letter D amounted to the M.U.C diagram for this one. So notice there, how the axis is the x-axis, because cosine is by definition the x-coordinate, the terminal point. So is negative 0.5, 0.87. So this one had a clearly visible axis point right there. And I believe that when you do the terminal points, the floor and the ceiling, what was the floor here? It was negative, oh, interesting. You start the search at negative pi over 2, you search until you get to pi over 2, and you don't encounter any solutions. So that's why the answer was no solution for part D. Are we in agreement on that? It was no solution? Yeah. Whereas on the next one, it was basically the same thing, but this time negative infinity to infinity. So for part E, same M.U.C diagram, but it ended up being 3 pi over 4 plus 2 pi k, and 5 pi over 4 plus 2 pi k for all k that are elements of the set of integers. Here's the mnemonic device. Upside down is for all k elements of the set. Remember that z is the letter that represents the integers. Just put a buzzing sound at for the s on integers. That's a reminder that z is the letter for the set of integers in the mathematical community. Well, there you have it. Question.
Wait, why is it no solution? Can you explain it?
Yes, I'd be happy to. In part D, the interval over which you were allowed to write solutions was something like negative pi over 2 to pi over 2. I don't know exactly where the parentheses and square brackets were, but what that means is, just imagine trying to get angles that line up with the angles that are in the M.U.C diagram. M.U.C, many unit circle diagram. Starting at negative pi over 2, we can begin our search looking for these green terminal rays. And I'm gonna rotate my stylus counterclockwise until I get to pi over 2, and that's the point at which I will stop my search. It's like, this is the floor, there's a ceiling. Searching, green terminal rays, I don't see any green terminal rays. None, there aren't any. There are no, on the interval from negative pi over 2 to pi over 2, there aren't any solutions.
How is it like not spinning the opposite way? Because wouldn't that be the same as like the range? Wouldn't that be the same?
Yeah, when we go from low to high. Now, a lower angle, see, to get into the negative realm, if I want to just start at 0 and find the angle negative pi over 2, I would have to rotate in the clockwise direction to get negative angles. And if you want to increase the angle, suppose we're starting at the bottom, if you want to increase the angle, you have to rotate counterclockwise to go from low to high, from lesser to greater. And so using those conventions, then we see there are no solutions. Okay. Further concept questions on the homework that's due today? Yes.
Where are the tick marks from again?
Yeah, those are from, it really amounts to trivia. I mean, we just noticed that when you take a look at the ratios of sides back from geometry in a 30, 60, 90 triangle, its sides are 1 to 2 to square root of 3. So when you look at even just linking back to SOHCAHTOA, which we say goodbye to SOHCAHTOA when we say hello to unit circle-based definitions of sine, cosine, tangent. But for sine, cosine, tangents, it's, you know, like 1/2 is 0.5, so that's why we have either plus or minus 0.5. For 45, 45, 90, it's 1 to 1 to radical 2, but when you divide by radical 2, it's over 2, radical 2 over 2. Yeah, oh yeah, so if you divide through, if you want a radius of 1, unit circles, think of the hypotenuse, just we want to collapse it down to 1. Just divide everything by 2. That's where the radical 3 over 2 comes from. So radical 2 over 2, if you were to type it into a calculator, is approximately 0.71. Another commonly obtained value is radical 3 over 2, which is approximately 0.87. So we just eyeball it, 0.5. In this case, it's negative 0.5, negative 0.71, so that just corresponds to negative radical 2 over 2, and then negative 0.87 is negative radical 3 over 2. Okay, so good question. Further questions, concept questions on the homework due today. Hey, would one person in each group just collect up the homework papers and serve your group by delivering that little pile to the table by the door? Thank you. Yes, go ahead.
So can I do both of them in different?
Oh yeah, absolutely. Absolutely. Just gonna pause the camera here for a second. Welcome back. Those of you who were absent for this lesson, just so you know, we did just finish up the unit circle quiz. So if you're absent, just take that before class when you return. All right, so let's take a look at the new material. The homework that is due on Tuesday will be to revisit problem 3, and this time do parts A and B. Today what we're going to learn how to do is M.U.C diagrams for tangent equations. So far we've learned how to solve tangent equations with the aid of the M.U.C diagram visualization for situations where it's either a sine or a cosine equation. Today we're going to look at tangent, also cotangent, because by taking the reciprocal of both sides, you can turn a cotangent equation into a tangent equation. So that's the story for the homework due tomorrow. Same worksheet. It's online. Problem 3, this time do parts A and B. So here we go. What's going on? I did show you briefly. I remember I was trying to teach it while people were running around in the halls making all sorts of noise. They were making a lot of noise in the hall last Friday. I was trying to teach during that time, and I basically just decided to give up and say, we can do this on Monday instead. So here they are. Do you? These are all of the possible M.U.C diagrams in your imagination for sine, And check this out. Here's all the M.U.C diagrams for cosine. They have that look to it. And it looks like someone rowing a boat or something. And then for tangent, the one we're going to learn today, all of the tangent M.U.C diagrams have like a straight line. It's not like those two rays that come together to form a V. No. Tangent's a different story. They all look like this. Why would that be? Well, here's how you draw a tangent M.U.C diagram. The key values that you need, the new trivia, are radical 3 over 3, 1, and radical 3. So the tangent of an angle, if you consider all 17 angles on the unit circle quiz that you just took, sometimes the tangent of the angle will be 0. Sometimes it'll be plus or minus radical 3 over 3. Now, if you go to your calculator and take radical 3 divided by 3, it'll come out to be approximately, make this a wavy equal sign to indicate approximation, 0.58. 0.58, 1 is 1. Radical 3 is approximately 1.7. So that's the trivia you need to know. It's worth just memorizing, but you don't really have to. If you have trouble remembering it, just go to the calculator and type in radical, which means square root of 3 divided by 3, and oh, sure enough, it is about 0.58. So let's take a look at an example. Suppose you have tangent theta equals radical 3 over 3. How are we supposed to think about all of the solutions to this equation? Well, the big picture that we look at is when you say goodbye to SOHCAHTOA, you say hello to unit circle-based definitions of all three trig functions, sine, cosine, and tangent, and their reciprocals. So if this is a unit circle with radius 1, and this is a terminal point P with coordinates x comma y, our non-SOHCAHTOA definitions are that for this angle theta, whether theta is positive or negative, the cosine of theta is simply the x-coordinate of the terminal point. The sine of theta is the y-coordinate of the terminal point. And by definition, the tangent of theta is the ratio y to x. You don't need a triangle. You don't need to go opposite over adjacent. You just go y over x. Now, for quadrant 1, from 0 to 90 degrees exclusive, SOHCAHTOA is consistent with these new definitions. I mean, think about it. If you did insist on drawing a triangle to find sine and cosine, okay, well, what's going on here? We got let me just pull it down here. I'm going to extract that triangle from the diagram. Here's theta. Here's the x-coordinate, the y-coordinate, 1. Okay, so the cosine of theta is adjacent over hypotenuse. Hey, the hypotenuse is 1, so it really is just the x-coordinate. Sine is the y-coordinate. Now, for tangent, taking y divided by x is kind of annoying on the unit circle. But here's what the M.U.C diagram looks like. The M.U.C diagram for tangent theta equals radical 3 over 3 has a circle. It's going to be a little bit smaller. We're going to draw a tangent line. The tangent line, x equals 1. It's a vertical line. But there's a second tangent line, and because of the camera, some of you may have to move to a slightly different seat if you want to get all the details and take in the whole show, but it's x equals -1. Now, why is that? It turns out that for any angle, if you want to get the ratio of y to x, there are some places where it's easier to calculate the ratio of y to x than others. Let's make this a fairly thick red line, like, okay, for let's say 31 degrees right here. Or let's go up to 46 degrees. This 46 degree angle. Yeah, at the terminal point, I could take the ratio of y to x, but it's a decimal division, decimal divided by decimal. Why don't I look at this point here on the tangent line? There's something extremely liberating about using this particular point. I mean, think about it. Y divided by x, that's just rise over run. The tangent of the angle really is the slope of the terminal ray. The easiest place to calculate the slope is where y over x has an x equal to 1. So on the tangent line, x equals 1, that's the ideal place to calculate the tangent of the angle. Because at this point right here, it's going to be 1 comma y, and y divided by x is just going to be the y coordinate of wherever the terminal ray hits the tangent line. So, oh boy, I've messed up my M.U.C diagram a little bit. I was mixing theory. Yeah, I should have put this. I realize the error of my ways now. I realize what I should have done. I should have put the tangent line here. It said, whoop, there it is. That's a point 1 comma y. So I use, this is the best point to use for calculating the tangent of the angle. Now, this is unfortunate. Some of you, because of what I did here, you might have to go back and erase, or maybe even just start over your M.U.C diagram. Because to be clear, all you need for a tangent M.U.C diagram is a circle, 2 tangent lines, 8 ticks. The tick marks will be at 0, which goes like this, 0, 0.58, 1, so make sure that this tick mark is level with the top of the circle, 0.58, 1, and 1.7. The other 4 tick marks are at 0, 0.58, 1, and 1.7. Even though we're down here, these are positive ratios of y to x, because you know how in quadrant 3, both the x-coordinate and the y-coordinate is negative for all these points? Negative divided by negative is positive. So if tangent is equal to a positive number, then the 8 tick marks will be in quadrants 1 and 3. If the tangent of the angle is equal to a negative number, then the 8 tick marks will be populated half in quadrant 2 and half of them in quadrant 4. So if I want to get a M.U.C diagram for this equation, I place a clearly visible tangent point right here at about 0.58, which is it's an approximation of radical 3 over 3, and right there. Those are the 2 tangent points where we can then put the terminal ray at the origin, fire it out to hit this target, fire it down into quadrant 3. There it is. There's a graphic representation of all terminal rays of angles whose tangent is radical 3 over 3. And so based on that M.U.C diagram, I can now draw the conclusion that theta is an element of the set. You just did the unit circle quiz. What's this angle? This one is pi over 6. This pi over 6. So you could do the long way. You could say pi over 6 plus 2 pi k, and 7 pi over 6 plus 2 pi k for all k elements of the set. But look, with tangent, they're always lined up in a straight line. So you could shorten this up, but say pi over 6 plus pi k for all k elements of the set of integers. That's shorter. So, but if you want to spend more time writing out the solution, you could do the 2-layer approach. You could do pi over 6 plus 2 pi k and 7 pi over 6 plus 2 pi k for all k elements of the set of integers. Now, let's see if you can do one on your own. Would you please draw a M.U.C diagram that represents the solutions to all angles, that represents all angles theta that are solutions to the equation tangent theta equals -1. Draw an 8-tick tangent M.U.C diagram. Before you draw the terminal rays, see if your 8 ticks match up with my 8 ticks. Doesn't take long to draw a M.U.C diagram. get a quick visual. Is there a volunteer who'd be willing to tell me what the solutions are to this equation? Unrestricted, just, if theta represents a real number, what is the complete solution set for this thing here? Who can interpret this muck diagram and can tell me what the set of angles is? Eli, go ahead.
Oh, wait, I don't know the technical numbers. Okay, so 3 pi over 4. And then what's the next part you would do for?
Well, what would you have to add to 3 pi over 4 to get to this angle over here?
Well, you can just do it for every pi instead of every 2 pi.
Yeah, you can do plus pi k.
That's what
And then, do you know what upside down a represents?
for all.
Yeah, it's the English phrase for all. So it's for all k that are elements of this set of, what letter should I use here? Which stands for?
Integers.
The integers. So you can do it like that, or you could say negative pi over 4 plus pi k for all k elements of the set of integers. Or you could say 7 pi over 4 plus pi k. I mean, it doesn't matter what this first one is. Point is plus pi k will get all the other ones. Or you could do the 2-layer approach. You could say negative pi over 4 plus 2 pi k, and 3 pi over 4 plus 2 pi, 3 pi over 4 plus 2 pi k. Either way. Now, what you're doing there is sort of thing that if you had the software operating in your mind, you're saying, okay, you like negative 0.58, negative 1. It's like, that's the one. So you're now ready to complete the homework, which is due tomorrow.
Please come to the front office. Mia and
Problem
Katie
3,
Weinreich,
you're dismissed.
Emily Moses.